Student, today I want to discuss with you about two concepts. Actually, two concepts. One is digital sum, and another is the relation between digital sum with perfect cubic number or perfect cube. In general, we can say that because I have seen in your textbook, class 10 mathematics textbook, exercise revision 3, there is a question where you have been asked to guess whether a number is a cubic number or not. So for that, if you are to answer that question in no time or quick time, especially in the MCQ section of your SSS examination, then for sure you are to uh, you are to know, you are to acquire a new method so that you can answer very quickly. Okay, so today I am going to teach you, or rather I would say I would try to teach you a very simple trick where you will be able to, using that trick you will be able to find a number, whether a number is a cubic number or not. First of all, I want to show you some numbers, and especially cube of that numbers. So from 1 to 10 I have written here from 1 to 7. Now I am going to write 8 cube. 7 cube already I have written. 8 cube is I think 512. Okay, 9 cube will give us 729. Okay, and 10 cube will give us 10 into 10 into 10 1000. Okay, hope these are correct. 8 cube, 512, 9 cube, okay, 81. Okay, okay. So first of all, I want you to see this thing. Look at this number 1. 1 cube has a value 1, 2 cube has a value 8, 3 cube 27, etc, etc, and so on. Okay, so if a number ends with 1, this also gives us the concept that if a number ends with 1, then the cube of that number will also have 1 at the end. Okay, if a number ends with 2, that number, the cube form of that number will have 8 at the unit place, or cube of that number will end with 8. If a number has 3 in the unit place, at the unit place, then cube of that number will have 7, will have 7 at the unit place. If a number ends with 5, cube of that number will end with 5. If a number has 8 at the unit place, the cube of that number will have 2 at the unit place, so on. Okay, now I want to show you, I want to divert your mind from this topic to another topic, another concept, this digital sum. What is digital sum? Okay, digital sum, I want to show my screen whether it is okay. Digital sum, what digital sum says, if we add on the digits of a number until we get a single digit, that single digit or that last sum is called the digital sum of a number. For example, let me take a very simple number 23. So what will be the digital sum of 23? We are to just add 2 with 3, it will give us 5, a single digit. So 5 is the digital sum of 23. Let me take another example, bigger example or bigger number, 207. So if we add 2 with 0 with 7, then we will get 9, which is a single digit. So the digital sum of 207 is 9. Let me take another example of a bigger one, 1079. Then if we add 1 plus 0 plus 7 plus 9, what we will get? We'll get 16 plus 1, 17. 17 is not a single digit number, it's a 2-digit number. So we have to add again 1 with 7, then 1 plus 7 will get the single digit 8. So 8 is the digital sum of 1079. Okay, now the concept of digital sum, I will apply with this number. Okay, now again come to this part. So 1 is a single digit number, so I will write here 1. Next, 8 is a single digit number, I will write here 8. 27, not a single digit number. So what will be the digital sum of 27? 27, 2 plus 7, 9. Digital sum will be 2 plus 7, 9, 9. So I will write here 9. Next 64, not a single digit number. 6 plus 4, 10. 6 plus 4, 10, 10. Not a single digit number. So we have to add again 1 with 0 to get the single digit 1. 1, again 1, comes 1. 125, 125. 1 plus 2 plus 5. That will give us 8, 8, 8. The single digit number 8. I can write here. Next one, 216. 216. 2 plus 1 plus 6 will give us 9. Single digit 9. Okay. 343. 4 plus 3, 7 plus 3, 10. 10. 3 plus 4 plus 3, 10. Not a single digit. So 1 plus 0. Then we get the single digit 1. Okay. Okay. Next 512. 512. I want to write here 5. I want to show my skin. Okay. 5 plus 1 plus 2 will give me 8. 8, single digit. Okay, single digit 8. Next 729. 7 plus 2 plus 9 will give me 18. Not a single digit. So 1 plus 8 will give 9. The single digit 9. Next 1 0 0. So 1 plus 0 plus 0 will give us 1. Okay. Next one. So what we have seen, or have you seen any similarities in this pattern, or is there any relation between digital sum and perfect cube of a number? Yes, we have definitely seen a very beautiful pattern. Is that 3 specific numbers, okay, 1, 8 and 9. 3 specific number 1, 8 and 9, okay, are repeating in all the cube, in all the digital sums of this cube, perfect cubic number. Okay, all these perfect cubic numbers, when we try to find the digital sum of all these perfect cubic numbers, then we are getting only 3 specific numbers, that is either 1 or 8 or 9. So what does this concept or this observation suggest us? Okay, we can say that if the digital sum of a number happens to be either 1, 8 or 9, there is a very bright chance or very good chance that that number might be a perfect cubic number. Might not be a perfect cubic number, but there is a chance that it might be a perfect cubic number. Okay, if the digital sum of a number is either 1 or 8 or 9. As we are not sure whether a number will be a perfect cubic number if this condition satisfies. So on the contrary, or in a different way, we can write, or we can say that, I just want to rub this one, I can say that, or we can say that in a different way, if the digital sum of a number, does not happen to be either 1, 8 or 9, then for sure, for 100% or 200% sure, for sure, that particular number will not be a perfect cubic number. Simple as that. So we have learned that a new concept to find out whether a number is cubic or not, perfect cubic number or not. The thing is that if a digital sum, if we add on the digits of that number, if that summation, okay, the digital sum does not happen to be 1 or 8 or 9, the digital sum does not give us the number 1, either 1 or 8 or 9, then that number is not a perfect cubic number. It is 100% sure. If give rise to 1, 8 or 9, we can say that the number might be a perfect cubic number or may not be a perfect cubic number. It is not sure. But if the digital sum is not between these numbers, okay, not between these numbers, then we are sure, we can assure that the number is not a perfect cubic number. For example, I want to take one example from your textbook to show you. For example, 3757 from revision 3, and you have been asked to guess whether this number is a perfect cubic number or not. So in that question, what you will do, you are to adjust these digits 3 plus 7 plus 5 plus 7 until we get a single digit. Okay, first 3 plus 7 10 15 7 22, it is not a single digit number, so we are to add again 2 with 2 to get the desired single number, that is 4. So as we are not, we have not got one, either 1 or 8 or 9. In this case we have got 4 as a last digit, so we can say that this number is not a perfect cubic number. Simple as that. Okay, so I think you have understood today the concept, this concept or this idea of guessing out whether a number is a perfect cubic number or not, and I think this video will be beneficial for you in the coming SSLC examination or also in the longer run. And actually what happens, this type of question actually arises in the MCQ section, where you will get very little time to give answer, and you will get very little time to give answers quickly actually. So you will need this type of quick method or concept in that time. So hopefully I think you all have liked my video, this video especially, and do subscribe my channel, like my channel, share my channel, and God bless you, and love you all. Bye bye. Thank you.